Then it's time to go to the closing and the final keynote for today. So thank you for being part of this. It's much appreciated, and I'm sure the footage will be awesome. So closing for today. The third day of JuliaCon, depending on how you count, second day maybe. And the first and last day of PyData Eindhoven 2024. My name is Rob. I'm one of the co-organizers of PyData Eindhoven, and it's my great pleasure to speak to you today. I just have a few closing remarks before we move over to Sam for the final performance of today. So first of all, thank you for being part of this. It's been a really amazing day. Just a general thank you from the PyData team as well for letting the JuliaCon, toward JuliaCon for letting us be a part of this. We're really happy to have put this together with all of you. Again, why do we do this? Especially PyData and Julia as well. We are financially supported by NumFocus, and NumFocus maintains and financially contributes to a vast number of open source projects, which I think is really cool, and it helps us share knowledge. And I think the tagline is a perfect summary for that. Open code means better science. All of this wouldn't be possible without our sponsors. So a big cheer for our JuliaCon sponsors, primary of which ASML. Thank you. Sorry, Julia Hub, of course. Like it's so close to the Julia logo. Like it goes without saying. I would almost assume. Woo! Julia Hub. If I missed anyone that I should have shouted out, come find me at the after drinks. I'm sorry in advance. And then for the PyData sponsorship, all of these nice companies, primary of which Intel, our diamond sponsor. Thank you. And it would not have been possible without companies like these. This is a stat from PyData Eindhoven specifically. This is the number of euros that PyData Eindhoven has been able to contribute toward NumFocus because of events like this. And I think it's really worthwhile, and it shows the impact we can have as a community, and that's something we should be proud of. Now, all of this would not be possible without a great group of volunteers. This was last Monday at the pizza party at TUE, the local university here. You will have seen them during the day as moderators, as people handing out mics, as people helping you find your place throughout the stadium. The people with the black and white shirts, thank you so much. Yeah, you're the heroes of today. And then to put a name to all of these faces, of course it's not yet time to thank the JuliaCon folk, because the closing for them will be tomorrow, and you'll get the chance to see them shine here on stage as well, and be able to thank them on your behalf and on our behalf. I just want to shout all of these people out before I got to the PyData organizing committee. So all of the people I've had the pleasure to organize PyData with. Gareth, who's been, like, you can't fault him for his enthusiasm. He's the only person I know that could have brought together such a group and made that bridge between Julia and PyData. So Gareth, thank you so much for your effort. That's not to discount the other contributions here. I won't shout them out as much in depth, but the two Koen brothers, of course, Gijs and Alma. It's been my great pleasure to work with you all together. And I'm really proud of what we were able to do here today, working together with the amazing JuliaCon people. So, thank you. Again, there will be a more concise closing tomorrow for JuliaCon, but if you would like to get involved with the PyData chapter here in Eindhoven, feel free to send us a message if an event like this seems amazing for you to organize, or a local meetup even. We're always looking for volunteers to help put up events like this, and we'd love to work together with you. So feel free to reach out to us. You can also find us on LinkedIn or wherever on socials. And if you can't wait for the next edition of PyData Eindhoven, then PyData Amsterdam is also coming up in September, which is shaping up to be a great event as well here in the Netherlands. So I would love to see as many of you there as possible. Now, finally, some closing remarks. All of this, the program, that's what you come for, right? So the speakers, I think we've had 62 of them today. Thank you so much for your amazing contributions. It was not easy making a decision out of all the great proposals we received, but I think we can be very glad about the ones that we picked and the amazing talks that you put together for today. So thank you, speakers. Now, two practical matters. First of all, for the JuliaCon people who did buy a ticket beforehand, there will be a diversity dinner later after the closing keynote. So that should commence at about 6:30. This will be on the 3rd floor, where all the sponsor stands were today and where you had your lunch. I want to reiterate that you should have bought a ticket for this beforehand. It is sadly sold out. So if you didn't get a ticket, please don't go to the 3rd floor again. You will be refused at the door. They've got a fairly strict policy. For those that do have a ticket, I think you're set up for a great dinner. So enjoy that part. Then for the and I should, of course, mention that tomorrow for all JuliaCon attendees, there will be drinks to celebrate the closing of the conference. Because it's PyData's first and final day already, we do have PyData drinks after the closing ceremony or after the closing keynote, which will be in the Frits Philips lounge. So if you walk out of the stands, take a right turn and just continue straight on. You will walk into the drinks area, the bottle area, or you can just follow the volunteers with the white t-shirts. Now, without much further ado, I've been talking for way too long. It's time for the closing act. I would have said keynote, but I think you'll find that it's more an act. Sam is a speaker I greatly admire. I had the opportunity to see him last year in November at a conference in Utrecht. And I'm really glad we were able to have him come here, fly out to put this together. I won't spoil much more because I think Sam is much better equipped to tell it himself. Please give it up for Sam Aaron.
Hello, can you hear me? Perfect. Closing act, Sam Aaron, that's me. Right, let's find it. I don't have any slides, I'm really sorry. I haven't done slides for about 10 years. Oh no, there we go. Right, yes, this is what I'm going to talk about today. This is my project I've been working on for about 12 years now, I think, maybe a bit longer. In a space I've been working on for many more years, really. But this is the thing that has had the biggest sort of community growing around it, and it has interesting things to talk about. Has anyone here heard of this software before? Oh, that's awesome, brilliant. That's growing every time I give a talk. Well, you will all have heard about this by the time I've finished. And I heard it as well, because there's actually a bunch of things it does. But I think it's important to spend a bit of time to actually describe why it exists. And to talk about the background of it, because that's really the crux. It's not me here selling my software, which obviously I can't because it's free, it's open source, but not really sort of promoting it, really. It's more about promoting the ideas that it's trying to solve. And it's one of many pieces of software trying to solve the same problem. And this is my attempt. And the real problem was that I was working as a researcher at the University of Cambridge, and my contract was about to expire. And a couple of things happened at the same time, which were pretty lucky for me. One was that the UK government just released a new curriculum to teach computer science, which is amazing. It was an amazing result to have that. Not just teaching how to do logo designs or spreadsheets, although spreadsheets actually are amazing, and they're just more interesting than people can actually understand. But yeah, but the basic kind of ways of using spreadsheets and PowerPoint presentations, they were instead going to teach algorithms. Now, who here knows what an algorithm is? Great. Now, this is the problem, because I am not talking to the right audience. Because the real problem is, how do we get everybody else who aren't here, right, to understand what an algorithm is, and why should we get them to care? And in the UK, we just created this new computer science curriculum back then, but there was an enormous challenge. The enormous challenge was most computer science teachers, and I wouldn't say most, but possibly most, don't have a computer science degree. Can you imagine that for maths? Can you imagine that for physics? Right? Can you imagine that for sports, that they haven't got some real depth of knowledge of sports? Whereas in schools, computer science doesn't really have that benefit of having teachers who are really well qualified. So that's a real fundamental challenge. And the other fundamental challenge is society has no idea what computers are, really, how they work, right? And you can tell this by watching the TV. Right? I remember, I mean, it's a bit of a joke, but it really emphasized the point. I remember seeing a TV episode where there were these two hardcore hacker types, you know, and they were standing in this office, and they're like, oh no, and these like bells start whistling, we're being hacked, right? And they're like describing the hacking scenario. They're through the firewalls. They're around into the routers, as if it's like they're actually entering a building, you know, with like masks and stuff. And they were like furiously typing on this keyboard of this guy to try and like defeat the hackers. Obviously that's what you do. And then all the stuff was whizzing on the screens, because that's obviously what happens in real life. And then the lady hacker, she sort of shoves him aside, because obviously he's not doing well enough to defeat the hackers. But she doesn't take over the whole keyboard. No. She has half the keyboard, and he has the other half. And together, they defeat. Like, what is this nonsense? Like, society has no idea about what programming is, and this is a problem. And in schools, it seems to be like there's a real narrative that schools are there to teach computer science to make the next generation of you folk, the next generation of professional programmers. And to me, that's just bonkers, right? You don't teach maths at school to make the next generation of mathematicians. You don't teach sports at school to make the next generation of professional sports people. Right? They might exist, and you can engage them and get them started with those things, of course, right? But it's not the primary purpose, surely. Surely the primary purpose of teaching maths in school is to get people to understand how to think in a maths-like way, how to structure problems, how to break them down, how to really carefully and rigorously work through the answer, how to demonstrate the answer is correct, how to come with it from multiple angles, you know? And to have a conversation with others, regardless of actual language, to actually agree on this and to be really, really confident that the things you've described are actually what you're talking about. Not to make the next generation of professional mathematicians, but to help society have new tools to communicate with each other and to work together on problems. And sports, similarly, is not to make a new generation of professional sports people. It's just to get people moving around and running together and collaborating outside of the classroom, which I think is so important. And it's cruel almost that we make children sit down for most of the day. And I think, in 100 years' time, 200 years' time, we're going to look back on the schools of today and be quite shocked by what we do. And so these are problems, right? And so computer science is no different. So this is the challenge. And so the first thing that happened to me was that the computer science curriculum came out, and the second one was the Raspberry Pi computer just got born out of the labs at Cambridge. And that was an amazing success, obviously, that's just skyrocketed beyond anyone's belief. But back in the day, they had a charitable mission to teach computer science. Have since changed that. And they also had a real problem, which was these computers weren't really very good at teaching computer science, because most of the educational software that was being developed at the time was all targeting the web. Because, of course, you would target the web. But the original Raspberry Pi 1, I don't know if I ever had one of those things, was really cheap and really rubbish. And so you couldn't run, like you tried to open YouTube and it just froze, right? And so this was a really low-powered machine, and it was low-powered because it was very affordable, but there was nothing really around. So they had this challenge of, can we maybe get some software to develop to work on the Raspberry Pi to teach computer science? And I was like, my contract's about to end, maybe I can build something. So that's how this project gets started. But before that, I was working on this other piece of software. Let's see if I can find it over this thing. So I want to talk to you really, I don't want it to be language specific. The Sonic Pi default language is Ruby, which obviously not necessarily Python, although basically they're the same. I'm talking to Python people here, but they are basically the same, especially for everybody in the Western world. There's very little difference. They're both object-oriented, they've both got functional elements. Okay, the syntax is just slightly different. The communities are fundamentally hugely different, but from a language perspective, they're very similar. But I was very interested in Lisps. So that's my passion, Lisps. And I was looking a lot in the language called Clojure. We are a Lisp person in the audience, great. Parentheses rule. I was interested in Clojure because I was trying to solve. I was interested in concurrency. I was interested in immutable data structures. I think immutable data structures are amazing, and they really help simplify the problems that I work on in my head. And I was also interested in music. So how do I combine those two things together? And I also went to a conference where they had this party afterwards, which was pretty rubbish. They just got like a few people who maybe could play an instrument and banged them together. And I was like, surely we could code the music, was my thought. Of course, no one is coming up with anything new. Ada Lovelace, when she was working with Charles Babbage on the difference engine, she was looking at this machine and imagining in the future the evolution of these machines could potentially make music of our wildest dreams, right? That's hundreds of years ago. So none of this stuff is new. But anyway, I was working on this system. And it's worth mentioning this for just a moment because I thought this was pretty badass. This is like a pretty powerful Lisp environment for designing sounds, for implementing new features of sounds, for building new instruments. You've got all the advantages of this amazing synthesis engine called SuperCollider, which is an open source. We built a compiler which took the Lisp forms and compiled it down into these little synthesizers. And then we could use the Clojure to then control and manipulate and orchestrate these little synthesizers. And you could build all sorts of things that you could imagine. And super easy to do like distributed stuff as well, to have multiple machines communicating with each other, sending events to actually control and manipulate these sounds. And I had a band, me and my brother-in-law, we live coded together. We had a REPL that was shared, so we were into the same namespace together, manipulating the code together at the same time. It was pretty fun. But there was a real problem, and this comes back to the education, which was people come to the gigs and not have any clue about what we were doing. And that's not just people from society, like normal people who aren't programmers. That was obviously the case. And I got a really good review in a magazine once, and they're talking about all this, like how the music sounded, and it was like, this is great. And it ended up with great visuals. I'm like, the visuals are actually the code projected for the audience to see and to read, right? It wasn't visuals. It's like going to a Jimi Hendrix concert and saying, great wooden medallion. Don't know what the hell it was, why he was touching it, but it was a pretty cool object around his neck, right? This is going to the problem of a code. So that was a problem, but also the same problem happened for coders. They say, well, what's your environment? I go, well, it's the super weird Emacs setup that I've configured, and the language is Clojure, and you've got to learn, to do this, you've got to learn a whole bunch of esoteric stuff, which is super high friction. It's not that it's not achievable, but it's like a huge barrier to entry. And therefore, very few people took this stuff and did cool stuff with it because it was just too much work. You had to learn how to design a sound before you could make a sound. Right? It wasn't like you buy a keyboard and can make a sound immediately and press with the knobs. No, you had to actually learn synthesis design first. So this was a problem. And I didn't realize this was a problem until the Raspberry Pi opportunity came along, because I developed this software, I was performing around the world with it, having a great time, thinking this is it, this is my professional software, I'm going to use this for the rest of my life, it's brilliant. And then I got this opportunity to build something for kids. I was like, okay, maybe I can take this, make it really, really small. Like, I couldn't use this because my implementation was obviously crap, but also the JVM support for the Raspberry Pi at the time was also really, really rubbish. And so loading the namespaces took 7 minutes. It's like having a ZX Spectrum again, so that wasn't going to work. So I needed a language that was just quick, that I could work with fast. I'd done a bunch of Ruby before, so I thought, I'll take that, and I'll implement the aspects of overtone into a small thing. And so Sonic Pi was born, and so that's what it was. And then the reason why I'm mentioning this, because it's really important to talk about the difference between the objectives. So with the previous software, I built this thing that you could imagine building lots of different things, which is very powerful from a programming language perspective. And you must always have these debates all the time. Julia is better than Python because of. Lisp is better than C++ because of. I remember actually sitting down with the C++ chap. What's he called again? What was it? Sussman. Yeah, no, Sussman. Sorry. Strauss-Strupp, yes, I was right, yes. And I was in the computer labs at Cambridge, and he was sitting there, we were drinking a pint, and I said to him, this is my only conversation with him, what do you think about Lisps? And he looked at me with disgust, and then looked away. So this is a true story. And so the language arguments are ridiculous, but one thing I thought was really interesting that came from this move from Overtone to Sonic Pi was with Overtone, I built this thing which I could imagine building anything, but I didn't consider time. Like, it's okay to say, this language, I can implement anything with it and I can prove it's correct. Great, that's beautiful. And I've even got theorem provers which can go over the thing and prove it's correct. Great. How long have you got? If you've got a year, from a business perspective, that's fine. And it takes you a year. Great. But not all problems, you've got a year. Some problems, you've got 20 seconds. And you're looking at me like that's stupid, but when you're performing on stage, you literally have 20 seconds. So what is the range of expressive code you can write in your language in 20 seconds? Probably not that great, because it wasn't designed for that. And now, moving from Overtone to Sonic Pi actually taught me something. Because I designed this to work in the classroom, it was actually designed with teachers. I spent a lot of time observing kids using it, working with it, and all sorts of weird things happened. And I just realized that I need to build something that anyone can use really, really easily. And a whole lot of design decisions came in to optimize it in the classroom. And those design decisions turn out to revolutionize the way I work with programming languages and with systems. Because it actually reduced the cognitive load, it actually made it simpler to reason about the things. Obviously, you have to make shortcuts. You can't express all the problems. You're going to work in a specific niche. But if you optimize for that niche, then you can actually make some decisions that make working in that niche really, really effortless. And I'd done that because I was working in the classroom with the teachers. And so when it came to actually writing music in Sonic Pi, when I had to do some code in it, it turned out I could write less, like imagine like a vehicle. I could drive not as far to not as many places, but with a vehicle it would take me ages to get there, like a week or 2 weeks or 6 months. The kind of place I could go to here were much more immediate, much closer, a bit more like writing on a terminal, but that made it so much more fun and engaging and interesting, and allow me to learn much more rapidly. And I could actually wrap my head around the semantics of the system much more quickly because of that effortless, low-friction thing. So I think it really, when we talk about languages A, languages B, don't just talk about proofs. Don't just talk about correctness. Don't just talk about efficiency. They are all interesting things, but also talk about time, development time. Right? And know that different contexts are going to have different demands on each of those things. And there's not one solution that's going to work well for all of those things. Right, are we good with that? Making sense? By the way, if anyone's got any questions at any time, there's a cube thing going around, and you're welcome to ask me questions. So, what should we talk about next? So, yeah, going back to the classroom, it was like, well, actually building a piece of software to teach basic computer science and map it onto the curriculum wasn't that hard. It's not that hard, right, to build a basic little system. And the computer science curriculum UK is very simple. You've got like lists and data structures and algorithms and basic things, conditionals, right? So you can start to map all those things onto a variety of different things. So that didn't actually turn out to be the problem, although that was what I was paid for. That was my remit. The actual problem turned out to be, how do you get the kids to care? Right? It's not good enough to say, today you're going to do this, and these are your learning objectives, and we're not going to leave the classroom till it's done. Right? You've got to get them to be excited. You've got to get them to be interested. You've got to get it to be matter to them. Right? How many of you here have fun sorting? Right? You're all nerds, okay? Right? That's fine. But even then, only 4 of you, right? So I remember in the early days, they created these curriculum support documents to help the teachers. And one of them was, have fun with sorting. Like, who, like, what? And the other one was like, the other one felt like a bit weird because it was like drugs. It was like, give binary a try. Because it's a gateway, right? If you try binary and you're on, so like, again, like that might excite people like us who naturally fall into programming anyway. But I think the goal, at least for me, is not to make more professional programmers, as I said before, is to get society to be a bit more engaged, have a bit more knowledge about what programming is, to understand it a little bit more, so that that's the whole goal, obviously, so we can go to parties and talk to people about programming, and it'd be cool, right? Wouldn't that be nice? So this is seriously, like, So yeah, so this is the problem. How do you get them to engage? So in my mind, I was imagining, like, wouldn't it be pretty cool if I had like a, oh, I've got like some photos somewhere. Where's my photo? Oh, I killed the Finder. No, wait, it's the Pi thing preview. Yeah, wouldn't it be cool to like go to a nightclub, right? That's what I'm imagining. Tell the kids like this could be you one day, right? And imagining a system that could actually allow artists on a stage like that to perform with the same software that they're using in the schools, right? So this is what I imagined. And so I put all tons of effort into making this thing really rigorously good as a musical instrument. So timing, for example, I wrote like a whole, me and Dominic Orchard wrote this amazing, where are we? Paper describing this temporal semantics, and Dominic took the Sonic Pi code and wrote Haskell proofs to demonstrate the soundness of it. So we really went into detail about the timing of it. And also things about like the sound, how the sound system worked to make sure that it produced really interesting, useful sounds that musicians could work with. Things like effects and reverb and distortion. None of these things were on the curriculum, but they were important to talk about. So yeah, this actually turns out to be today. This is last year. This is DJ Dave. She's New York-based. Actually, she's moving to New York now. Live coder, and she's performing with Sonic Pi on that stage. So that now is a real fit picture. I go into schools and show them that picture. And I'll quickly show you one of the more recent things she did, because this is another thing. So I go into a school, and I'll pop out this video, and let's watch this for a couple of minutes, because this is all produced with the software Sonic Pi. There we go. Hold on, Sarah. So I go to schools now and show that, right? And instantly the kids are like, okay. Like, yeah, and today we're going to learn how to do that. Like, okay. And so this is important, right? You need that thing to capture people. It's not sorting algorithms. It's not binary, I don't think. I think music is one of many tools, but it's a fabulous one I've observed to work with to get them engaged. So yeah, so that's what I do, and then we throw it open. We have a go at making some code. So maybe it's time to do a bit of live coding, show you how to use this thing. But before I do, it's important just to recognize, just to go back and understand why we're doing this. So if you think about it, programming is something we do all the time for business purposes mostly, right? And that's unfortunate. And so this is me going to a classroom and not saying you could be the next Mark Zuckerberg or Bill Gates or whatever, right? Because I don't think they're necessarily the right role models to be looking at. I think Sarah Davis, DJ Davis, is a much more exciting role model for kids than a fabulous business figure. And a way to think about that is to imagine a world where the only use of written language was for legal documents. Would that be a world you'd like to live in? Because that's pretty much the world we live in today with programming. They're not legal documents, but business. Right? There's no plays, there's no love letters, there's no text to your friends, shopping lists. All the interesting human expression is removed if we only focus our language on business and legal documents or religious terms. Right? Or even religious terms are actually interesting because they really broadly represent society. But with programming, we need to somehow break out of this straitjacket which is holding us in, and understand that programming is not. This is a very, very good tool for business, of course. That's why we're all here. That's how you're all making a salary. But if we want to get the rest of the world interested, I think we need to understand how to communicate with them. And I think making it about being meaningful and being expressive and demonstrating how actually programming languages are incredibly expressive tools for human expression. It's not just a tool to get the machine to something. It's in the same way mathematics isn't just a tool to do equations. It's a tool to think in, to reason in, and to communicate with others in, and to express yourself in. Code is the same. And we need to find ways to get people to understand that. And so this is my attempt to do that. So this is Sonic Pi. It's free, it's open source, it runs on a Mac, it runs on Linux with a bit of fiddling, it runs on Windows, and also the Raspberry Pi. And the idea is it's designed to work in the classroom. So you type some code and you run it and it makes a mistake and doesn't tell you what it does. And this is important to talk about very quickly because most people in the world somehow, at least people I've spoken to, think that programmers are always working in a state where the program's working. How wrong is that, right? It's never working. It's never, ever working. Well, it does for a brief moment. You're like, yes! And then you're on to the next problem, right? It's not working again, right? So those fleeting moments it's working, but the rest of the time it's not. So actually getting people to understand that having an error, having an issue, be able to resolve that is normal, I think is a critical thing to start off with. And then it's understanding what are the magical words. So here we have the ability to play a note. And this is where there's one benefit over Python already. I don't have to put parentheses in there, which I know, like you could, from a professional perspective, can be a bit annoying. But actually, kids don't necessarily need to be faced with restrictive syntax immediately. In the same way, if you imagine saying to a child, I want you to draw me a circle, and they drew you like a crappy circle, and you have to reject it because it wasn't perfect. That's not the way to learn. I think when you work in a professional situation, if your circle drawer, your professional circle drawer, can't draw circles, that's fine, right? Yeah? And you're all professional, so this argument doesn't hold. But in a classroom, I think it's actually really important to allow syntax to have a bit more flex. And that's definitely something I've seen. So if you want to put the parentheses in there, totally fine, that's fine, it'll work, right? So you can do what you want, but the kids don't have to do that. So now we have the ability to play any note. That's the release time of like 10. Yeah, that's good. So the best classrooms are ones with really big bass systems. They don't normally exist, but that gets the kids' attention. So we're showing you a bunch of things here. We've got a function call. We've got some options we're passing there. This is just key value pairs, just a hash map. And there's a whole bunch of things that each synthesizer supports. And play plays a default synthesizer, which is a sine wave. And it's like going to a shop and buying a cool module with loads of knobs. But you don't know what the knobs are. You don't need to know them to play it. But as you learn about how you'd like to control the sound, you need to learn the special words. And then there's different synthesizers. So let's use the Prophet synthesizer. That sounds good. Sounds good with a good cutoff of like 70. And if I make the release time like 20. So you'll notice one thing already, perhaps, there's concurrency built into it. So those sounds are overlapping. Every time you press the run button, the screen goes pink. It creates a new thread of execution. That thread is executing the code in the block and playing at the same time with everything else. And so you're able to layer over it all the time. That's a lot of fun. So this is how to play drone music. If you're interested in drone music, go to town. You're free to like do this to create interesting like wobbles in the sign and the It's hard to hear actually with the Prophet. If we go back to the beep. Whoa, yeah, we can get the sine waves to really do some cool stuff with each other. So you're free to play any frequency. You're not limited to integers. Obviously, you can play floating point values. Totally fine, right? Cool. Next thing is think about how this works. So if I have a note like 70, and I have a note like 75, right? So imagine what this is going to do. So this is a way to learn Sonic Pi, is to write some code. Don't press the run button. Just try and imagine it, right? I can hear you imagining it, right? Cool. And then you press the run button, and maybe you're surprised, right? Maybe you expected to play one after another. That was a totally normal thing to expect. But this is a system which is designed for musicians, so time is critical. If you don't mention time, they are played sample accurately at the same time. So this is actually all ahead of time scheduled. So there's like a hard sort of local notion of time, which is thread local. And then it's sent to a scheduler, which then schedules those notes to be played at that time. So if we want to actually interact with the scheduler, we use the sleep command, and we're able to then play. Actually, it's currently at drum and bass pace, so that's why. Normally, the BPM is 60, so that you go to schools and talk about seconds, and that's great. So you don't have to think about like speed and tempo in the classroom. You just talk about time in seconds. But of course, you can change the BPM, and that sleep time will be a different period. That's why it's a bit faster than 1 second. There we go. But let's keep the BPM tempo. That's good. Actually, let's go back to 60. There we are. Nice. So there we are. We can play notes. Now at this point, you can actually have access to any melody you've ever heard of or ever will hear, and you can code it with those two commands. That shouldn't surprise you probably, because if you've looked at things like drawing tools, like the one with the robots, the pen up and pen down stuff. With a few commands, pen down, pen up, rotate, and forward, you can draw any picture, right? And kids do. And kids will take that and make really long. And my 6-year-old niece, I gave her this, taught her how to do this. You could just type and read. And she'd written 100 lines of code. And I was like, wow. And she said, I'm not finished. And she was typing away. So that's great, right? But of course, we need to get a bit close to where we want to be. So there's also samples that gives you direct. So the play command gives you access to internal mathematically defined synthesizers, which are operating in real time on the computer using this SuperCollider synthesis engine. And there's a whole variety of different synthesizers you can play with. We saw the Prophet synthesizer. There's a Beep synthesizer. There's a whole ton more. And if you like designing synthesizers, you can go and open up SuperCollider. They've got their own language. You design your synthesizer, and you can play it in Sonic Pi as well. So you're free to do that. And if you do that, please send me the synths, and I'll put them in for everyone else to use. Hello, question. Can you have multiple synthesizers playing at the same time? Of course, the answer is always yes. So use synth like Prophet. Yeah, and play note. I know, like E3. So if you don't know about music notation, just use the numbers. If you do, then you can use this representation as well. So that's great. I can sleep for, well, actually, I can just then use synth. So this is all thread local. So what we're actually doing is use synth Prophet. It's setting a thread local variable to say this is the current synthesizer. And it's linear. So at this point now I can go back to, I don't know, piano and play E4 and E6. they're playing at the same time. So yeah, and you're just saying at this point, this is the synthesizer, and you're going down. We'll get to the moment to talk about threads, and actually you can do this as well, multiple threads, but this is how you can do this. And it's also important to point out that it's only deciding the time of the start of the trigger, not the end. So it's not waiting for things to finish. That's the other thing to think about. Yeah, so there's samples. So I can play the drum breaks like this. There's a whole bunch of pre-recorded samples in there. They're all free in Creative Commons Zero license, so there's no sort of issues in terms of using them. But of course, you can pull your own samples in. You just need to put the path on your local disk to a WAV, FLAC, AIF, or OGG file, and it will play that file for you. Now, this is fun because I wanted to be able to do things like the stuff that musicians do. So there's a whole genre. First of all, people want to be able to change the speed of something. So if you want to go to hip-hop, you might want to do it slow and rap over the top. Or maybe you want to go back to the UK and do this kind of, yeah, right? So there's this as well. What do you think this is going to do? It's a trick question. Backwards, yes. Well, I can tell you I'm talking to programmers. Great. So we can play it backwards at like a quarter speed and make a horror film. Yeah. But also, I'm going quickly because I want to show you as much as I can. It was really interesting to think about. A lot of dance music is made by taking samples like this and using magic audio scissors to take the data structures of the WAV file and chop it up at the right points and then rearrange it. Like you might take a newspaper, chop up the words, rearrange the article to make a completely different article. So I wanted, again, to make this something that kids could use. So all the features of Sonic Pi I've designed so that a 10-year-old can use it. And so nothing I've put into it, I can't teach a 10-year-old child. So that's a huge filter of features. And it's taken a lot of time for ideas to be able to be not just something I could imagine, not something I can imagine implementing, not something I can imagine implementing and it fitting with the rest of the system, tessellating well functionally, but also something simple enough to teach a 10-year-old child. If our feature can pass through all of those, then it goes in. And so that was always a real hard thing. So I spent a lot of time walking, thinking. That was how I did most of the development. And so yeah, so like how do I think about doing that with that same kind of simplicity? Well, actually, it makes sense to think of a sample as a list, right? And so if I can use this onset option, I can pick out all the different hits. So it does feature detection on the WAV file, splits up the things, and then just treats it like a list. Great. So now I can do something like a loop, and sleep for a short amount of time, and ends, and now play that one, that's pretty fun. We'll play this one, pretty fun. Or let's use a lambda, which actually randomizes it. Yes! We're getting somewhere cool, right? Nice. You can now change this to like a different guitar sound, whatever. Doing the same thing. So let's do this. So let's have a loop, and let's have another loop. Let's comment this out. And in here, sleep for half a beat, and then we've got kick drum. Probably not loud enough. Let's make that a bit louder. Yeah, cool. So this is code that within a couple of hours, every single workshop I've ever given in, some child puts a hand up and says, I've got a problem, right? Now, this is a good interview question. Hopefully all of you will be able to see the problem, right? Because there's a problem. Right, shall we hear the problem if you can't see it in your mind? No, it's not the drums not long enough. Where is the guitar sound? Arrgh, that's annoying. Well, let's just really obviously make the problem clear, right? Let's swap them around. Where is the drum sound, right? We have a single-threaded program at this point, right? And loops are like black holes, they're stuck in the program, and that top loop gets the program forever. It basically says, forever, loop around this bit of code. So that's not cool. Now, I remember this girl, she put her hand up in this class, and she said she did the same thing, 2 loops at the same time. She just imagined it. We taught her loops, and she was cool. I'm going to play the 2 loops at the same time. Why can't I hear them at the same time? I was like, yeah, I can see why. And this is the point where we were actually developing the lessons on the fly. So me and the teacher would sit afterwards, and we'd talk about what we're going to teach the next lesson, and then I would go home, develop a new version of Sonic Pi, and then use that new version to teach with. It was like really rapid iterations, like on a weekly basis. So this, in my head, this is like we'll do this next time. So I said, can we do threads? And the teacher's like, is it on the curriculum? I'm like, data structures, conditionals, algorithms. No, it's not on the sheet. Sorry, no. And so I went back to this girl and went, I'm terribly sorry. I didn't say this, I wish I'd said this at the time. But terribly sorry. If you want to play the drums at the same time as the bass, you're going to have to wait till you're 18. You know? Because when you're 18, you can go to university, and they'll teach you concurrency, right? And that girl, when I said, sorry, you can't do this, she switched off. She looked out the window, and it's like, what a piece of crap. She didn't say this, what a piece of crap software, like music software, doesn't let me play the two things at the same time. So she was disinterested, right? And it was tragic. This is like, imagine, because I don't know if you've ever gone to a school to help teach computer science. If you haven't, please do. Schools are crying out for your help. And when you go in, you'll be amazed how little time the teachers have to actually do anything. Stop spinning around on your chair, just be quiet. Everyone, I want you to come in, I want you to log on to the system. Like, it takes 15 minutes to even get them to be ready to do anything. And after that 15 minutes, what's your one sentence you're going to say that's going to get them excited? Is it open up IntelliJ? No, right? What is it, right? So this girl, so that not only had this girl paid attention and learned the constructs that we were teaching, loop, she had taken it further. She'd imagined what else she could do with it and given it a try on her own bat. And so this is like a little seed that's just like popped out the ground. It's like, hi, look at me. I can say it's so exciting. I can try all these different things out. And then I'm coming over like, squish you out because it's not on the curriculum. So this is my fundamental argument I had to have with the people who were funding me and the approach. They just wanted to focus on the curriculum. If it's on the curriculum, don't do it. The kids did want to do it. They wanted it to be engaging. So it's like, how do you do this? So as a programmer, the cool thing is we don't have to stick at this, right? We don't have to stick at loop. Is loop the best thing we can do? Is that cool? Well, it's useful, but actually, we could imagine building new kinds of loops. This is a live loop, and live loops are cool because they need to have names. This is Thijs, it's a Dutch name, look. And this is Kate. And once we change them to live loops, actually it injects a few cool tricks, actually. So first of all, we've got our concurrency. So we don't teach loops for Sonic Pi, I teach live loops. Teachers have no idea that it's a fancy loop. They just know it does the loop, so they can tick off the curriculum. It's repetitive, right? Great. But it also has this concurrency thing. But there's one thing else, right, that we haven't got to when we're talking about sort of people performing on stages. How many musicians have you ever heard, right, performing on a stage where they're like, right, I'm going to make some beats, yeah. Oh, the bass drum's a bit too loud. Let me just stop it. Right, I think I'm going to... And let's try again, right? Right, because that's the normal programming workflow, right? You do your design, right? Then maybe if you do your tests first, you do that, or you do your type system first, and then you write your code, and then you run some other tests, and you evaluate it, and you see if you like what it does, and it doesn't, it's not working, and you delete it, well, you delete the running memory model, and then you go back to start, right? And you iterate. And we can talk about how long those iterations should be, the different lengths of time. Should it be a second? Should it be a week? Whatever. But it's literally that's what you do. You run it, you try it, you stop it, you reset it. Even with a database, clear the database. Let's populate it with some new data again, right? Clear the database. Because it's much easier to know that you're starting from a sound point. Totally makes sense as an engineer. Does not make sense as a musician. What you really want to be able to do is like, let's turn it off and turn it back on. Let's change the sample to like the loop amen sample. Right, have it just swap in place without losing time, right? This is all like in time. Because the concurrency thing is not just about things running at the same time, which is mostly what we think about when we talk concurrency. Here we have to work in time. Right, so the threads are not just executing similarly, it's not a schedule that's randomly going to bit of you, bit of you, bit of you, which it's actually what's happening, but there's also some clever stuff behind to make sure that the timing of these things is all actually exactly right. So yeah, there are languages which you have deterministic garbage collectors, for example, which can help you to make that stuff much more deterministic. Determinism is the way to go as well. But yeah, these things are in time, and you can live code them, you can modify them as they're playing, which is a huge amount of fun. I don't know how long I've got left, by the way. What, is it? I started like at 22, didn't I think? We've got like 20 minutes left, 15 minutes left? Anyone in charge? No? No? Well, I'll keep going until you kick me out. Does anyone else have any questions at this point, right? And I can go in the right directions. Yes, question.
So, say you're a musician and you're kind of used to piano or something. So, can you connect like a MIDI controller?
The question is, can you connect a MIDI controller? Yes. So, Sonic Pi, actually, I did a marketing picture for this. Where are we? Yeah. You can connect lots of things, right? So yeah, so you can do audio, so there's multi-channel audio in, so you can have like lots of different channels. If you've got a sound card with like 8 audio inputs, you can access all of those. You can spit out to a multi-channel audio as well. MIDI, of course, in and out. And able to link, which is a really cool protocol for synchronizing different musical applications together really well in time if they're on the same network. It's just like network detection. And then, of course, open sound control, which is just a very simple network protocol. So you can send messages between versions of Sonic Pi, or with, there's a whole bunch of like VJ tools which will receive open sound control messages, or super easy to write. Like people say, I want to control my hardware thing, flash a light. And it's like, well, just write a little Python thing which can receive OSC and then map it out onto the hardware, right? So, question over there, yes? The question is, does Beardy Man use it? No, he does not. I did have a phone call with him once, and he seemed interested when I showed like a very complicated diagram of the synthesizers, but he's not particularly interested in the coding aspect, I don't think. I think he's interested in coding, but not live coding, I don't think. So, no. But Beardy Man's a very interesting musician who does a lot of live looping and uses his voice a lot for the sounds, and he's a super cool guy. More questions? Yeah?
So, oh, sorry. Did you want to go first? I could. Okay. So, more back to the teaching kids side of things. So, when your students are done, what is their view towards programming after they've finished your, highly evolved, tried and tested curriculum now?
Maybe it's about we'll spend time looking at this little video here. So there was a project organised by a group of people in Finland, and they took a bus and took it to Africa and taught 2,000 African women and children, girls predominantly, how to code using Sonic Pi. And they made a really cool video. It's 14 minutes long, so I'm not going to play all of that. But you get to understand, actually, that the coding, when you're watching the video, is not something they're teaching. It's something they're actually experiencing and sharing with each other and talking about the compositions they're making. So these two girls, a little bit before, they're talking about how it's like sounds of the Zulu and sounds from African plains, and they're really resonating with each other about what they're doing. Not like, oh, I use an if statement, and the syntax was like no, they were like talking about the expression. And so yeah, here's like just a couple of minutes that shows look at their facial expressions, and then imagine this to answer your question. It's not just about do they understand coding, it's how has the coding experience affected their experience, their understanding, their appreciation of what coding is. Right? And look at this.
So before this, like
I smear like pies. Enan, aski segar.
Kalau tiene hirtu kemarin.
So imagine that being your classroom where you're learning computer science, right? Wouldn't that be a much better place? So hope that answers your question.
Thank you.
Any more questions? Down here?
Does this work? Oh, yeah.
Yeah.
Pretty amazing. My question is, so the idea of programming music is not new, so to say.
Not at all.
And to me, it reminds a little bit of this old trackers that were implemented in Sega playing platforms, gaming platforms. Do you derive any inspiration of what is out there already in terms of like how the music is being built and tailored, so to speak?
Yeah, my inspiration. I mean, trackers is a really thing dear to me. I remember my mum was a teacher, and she was helping to organise a school musical, and they were taking Joseph and the Amazing Technicolor Dreamcoat, and they didn't have any music backing for it. So I actually got the book and they used a tracker to actually code with the tracker the entire score, and then they use that then to play the piece. So I love trackers. They're definitely very interesting. They're much more like a spreadsheet way of an interface versus code. There's in the live coding world, there's been many years of people doing all sorts of interesting esoteric languages, and I can name loads of them. And like Tidal Cycles is a really fabulous alternative. There's Strudel, which is another version of that, which are on the web. The Superclide language itself, there's tons of them. My focus was particularly to focus on education, like how do I build something? That's not just, Overtone was my, let's build a thing for musicians. Sonic Pi was I built a thing for teachers. And actually it turned out, as I said before, that that focus on teachers made me do some interesting design decisions that I wouldn't have perhaps made. But certainly there's a whole, you could never do anything on your own. So probably the biggest inspirations for me were Superclider itself, and Thor Magnusson as well. He built some really, really cool systems. And also Andrew Sorensen in Australia built really cool list-based systems, and I was amazed by the kind of things you could build with those things. But they were all trying to be much more professional and fancy, whereas I was trying to be much more simple. So yes. Any more questions? Yep.
Do you ever get a critique from the kids or from anybody else that it's a bit contrived, that it would be simpler to make music on a different application? Or
That's a very good question. No, actually, but I do get that a lot from musicians. And I found, actually, I really thought that the code music thing would be a really cool way to engage with professional musicians, particularly those with a classical background. I remember having a conversation with a teacher who was a music teacher, and he'd been recommended to speak to me by one of his friends who said, Sam's doing some cool stuff. And he was there's a lot of gatekeeping in music. So he was like, it's not real music. It doesn't do blurgy-blurg. And I'm like, it's something in Italian, right? So I'm like, what is this thing in Italian? Well, what is it? And he's like, and he described the sound going loud, whatever it was. And I listened to him, and I was like, okay. And I coded it up, what I thought he'd said, and played it back to him. And I'm like, oh, yeah, okay. But what about bluissimo? And we did this like 4 times in a row, and every time I coded what he'd said, and it was what he wanted, but he still was never going to be convinced this was real music. And there's a lot of gatekeeping in the music world, which is really deeply frustrating. Even I did a performance in the Royal Albert Hall, and we had like a live coded quartet alongside, I've got a picture of it actually here somewhere, alongside a bunch of other really cool musicians. And so here we are, look. Choirs and string or whatever. And I remember after that, I was like trying to say this, now I can talk to the violin players. Now, clearly, we've got some kudos, right? No. I was like, but did you hear the syncopated rhythm? No, they weren't interested. So I think that the kids are very open-minded. They're really interested. They're not there to make a musical track, so they're not necessarily aware of other approaches for making music. They're just enjoying themselves. I think if you've come predisposed with approaches, then you're more likely to look through that lens, and that might give you that potentially negative opinion. But even then, I sat and had dinner with the CEO of Ableton, which is one of the biggest DJ production software, and he was really positive about Sonic Pi. We talked a whole bunch about things that Ableton can do that Sonic Pi can only dream about, and a lot of that's because Ableton is a vastly wealthy company and can pay people to do cool stuff. And it's like, I was like, how do you do this particular feature? He said, oh yeah, we have a whole team of mathematicians who work on that problem. I'm like, Great, that's good for you. But there was also, the alternative is true too. There's a whole bunch of stuff that you can do with Sonic Pi and code-based tools that you can't do with these GUI elements. So I think it's open for everybody. So if it's not for you, then just in the same way a saxophone isn't for everybody, but a piano might be. I think that's the way to think about it. But not in the classroom. In the classroom, the kids they just saw it as a really fun thing to do that wasn't boring making sorting algorithms, I think.
And what about the reception within electronic musicians?
What is the reception of electronic musicians? I think there's gatekeepers everywhere. So it's slow. And also, if you're a professional and you've developed your workflow and you're happy with it, you're not going to switch it out to something radically different. So I think we need to wait for the next generation of musicians to use tools like this to see if it ever has any legs, rather than imagining current musicians who are high profile to suddenly just switch up. I'm not going to see, although it would be amazing if Taylor Swift were to make a track with Sonic Pi. Could you imagine the social impact? Could you imagine that, right? How many of her fans would suddenly become coders overnight? It would be revolutionary. You laugh, but it'd be unbelievably cool. But it's very hard to get someone of that status to switch into a completely different process. Question?
Could you show us a little bit?
Yes, certainly I can show you. I mean, how long have we got left? Half an hour left. Have we got time? I'll show you. Shall I have a couple more questions, and then I'll show you some things? Got loads of questions, that's the thing. The organisers need to stop me. Hi.
Hey, this is amazing.
Oh, thanks.
What do you miss about Overtone? Or the first system, if I forgot the name of it.
That's a really good question. What do I miss? The first thing I missed was Clojure promises. So Clojure has a really nice promise. It's not like it's kind of like the JavaScript promise, but JavaScript you don't actually have threads. And so Clojure promises is like obviously a box. You can put a value in at some point later. So I built everything in Overtone around promises. So that was the first thing I actually built in Ruby, was my own implementation of a promise to allow me to do all the concurrency stuff. But other than that, I mean, I miss Lisps. I miss working with a Lisp. I think they're lovely. And a Lisp combined with an editor that understands the syntax is a beautiful thing, because you're not typing text, you're actually manipulating the AST with shortcuts. And that's a really, really, really lovely thing to work with. So I miss the Lisp. I mean, in Overtone, you had the ability to design your own sounds. I had the compiler, and I guess I missed that a little bit. But it turned out for me the level of abstraction is not the one where I want to be on stage designing the synthesizers whilst I'm performing. Some people do that, pretty cool, like too risky for me. I'd much rather spend time in the studio practicing the sounds I've got and then to work with those. So, yeah. So I guess it's the Lisp. Yeah. Shall we do a demo?
Yeah.
Oh, sorry. If you're anyone around here tonight, if you want to chat with me. So Sonic Pi has a few different things. Like this is the normal mode. We've got DJ mode, of course. We also have like a mode for people with low vision, which is a critical thing, so high contrast. Let's go into the DJ mode. And so here I've got some code I've written before. And I'm just going to pull in some samples I've downloaded from the internet I paid for. So this is a really good way of getting started, is to find samples of the genre you like, get the BPM set to the right thing for you, and just play with it. So I'm going to do some drum and bass. So this live loop here, it's spinning around, every 64 beats, playing the pads and the voice. The live loop works by swapping the code in the background, and it's only when the live loop spins around the new code is executed. So after the 64 beats, we should hear now a bass coming in your face. Yeah, see?
Balance, no bass, you better be afraid. Not hot, not great, you've never been this way. No, we'll never be the same. I know, you're screaming out my name. Give me eyes, give me a break. Give me all the things so I just can't escape. Higher than a mountain, even better than a dream. Flying like a dragon that I never ever seen. Balance, no bass, you better be afraid. Not hot, not great, you've never been this way. No, we'll never be the same. I know, you're screaming out my name. Give me eyes, give me a break. Give me all the things so I just can't escape. Higher than a mountain, even better than a dream. Flying like a dragon, no, I never ever seen. Balance, no base, you better be afraid. No heart, no rate, you never been this way. No, we'll never be the same. I know, you're screaming out my name. Give me eyes, give me a break. Give me all the things so I just can't escape. Higher than a mountain, even better than a dream. Flying like a dragon, no, I never ever seen. Balance, no base, you better be afraid. No heart, no rate, you never been this way. No, we'll never be the same. I know, you're screaming out my name. Give me eyes, give me a break. Give me all the things so I just can't escape. Higher than a mountain, even better than a dream. Flying like a dragon, no, I never ever seen. Balance, no base, you better be afraid. No heart, no rate, you never been this way. No, we'll never be the same. I know, you're screaming out my name.
Thanks so much, Jan. I think everyone really enjoyed that. Oh.
Thank you. I can't take this on my plane home, so we need to drink it tonight.
Ooh. Drinks for Sam.
Yeah.
You will be around for a little while longer, so any more questions, keep them coming. And in the meantime, if you are going to the diversity dinner that's starting in a few minutes, actually a few minutes before now, so please make your way over there. And for the PyData drinks, feel free to follow the people in the white shirt. Otherwise, if you're here for GLACon tomorrow, see you then. Thank you.